Alright, so now we need to find the points at which the graph of the equation has a vertical or a horizontal tangent line. So here I have this equation and I need to find the derivative. So again, it's going to be 8x dx. So now we've got 2y dy minus 8 dx plus 4 dy equals 0. And we're going to divide everything by dx and solve for dy dx. Goes away, dy dx is 2y plus 4 equals 8 minus 8x. And doing algebra, we have this as our first derivative. Let's see if we can reduce this. We have 8, 1 minus x, and then we have 2, y plus 2. That goes into there. So there is our first derivative. 4 minus 4x over y plus 2. First derivative, we're done with that one. What it's asking us, though, is find the points at which the horizontal, or find the points on the graph which has a vertical or a horizontal tangent. Well, the horizontal is when the derivative equals 0, and that only occurs when 4 minus 4x equals 0. So I factor this, and now we're looking at x equals 1. I need to know the points that that goes to, so I substitute 1 back in and solve for y. 4 plus y squared minus 8 plus 4y plus 4y squared minus 8 plus 4y. And so now what we're going to look at is y plus 4. So we're looking at y equals 0 and y equals negative 4. So we have horizontal tangent lines at the point 1, 0 and at the point 1, negative 4. Horizontal tangent lines. Now where are we going to have vertical tangent line? The vertical tangent line is when y plus 2 equals 0. It's where it's undefined. So when I solve for this, I get y equals negative 2. At what points does that occur? We put it back into the original. 4x squared plus negative 2 squared minus 8x plus 4 times negative 2 plus 4 equals 0. 4x squared plus 4 minus 8x minus 8 plus 4 equals 0. These go away. 4x squared minus 2 equals 0. And now what we have is that x equals plus or minus the square root of 2. So we have vertical tangent lines at the point negative 2 square root of 2 and at the point negative 2 negative square root of 2. That's how you're going to do 45 on your homework. So in problem 48, we are going to sketch these graphs, see where they are orthogonal. That means that the tangent lines are perpendicular to each other. So I have a parabola equals, or I have y equals the square root plus or minus of x cubed. You could graph that. And then we know this is an ellipse. So we're going to have an ellipse, and we're going to have a square root function. So let's see what that looks like on a graph. So I put these in here. Let's see what our graph looks like. There is my square root, there's my other square root, and there's my ellipse. Now what I need to know is where these intersect. So I have to find those intersection points. So we're going to find the intersection point, second calc, intersect, first curve, second curve. Let's see where it takes us. Intersect, no, I don't want that one. Second calc, intersect, and I need to move closer to the intersection point. Let's see, I get the value, it's thinking, 0, 0. Again, it's not what I want. Zoomed in so we could actually see the points. Second, calc intersect. And I need to move close to this intersection, go to the next curve. I don't want that one. I'm going to go to the next curve. Don't want that curve. Nope, that's not the right curve. So let's try, nope, there we go. And now I'm going to move it. Since I have 4 equations, I need to make sure I'm on the right curve. And so now, let's see what we get. Somehow I got off the curve. So there's the negative. I want the positive. There we go. Second curve, enter. Didn't like that. 5. First curve, let's move a little closer. Where am I? All right. I calculated the intersection and it is at about 1. So I'm going to call it x equals 1. I think it's a pixel issue. Second, calculate, intersect. I need to go to another curve, which is down here. Enter. In my second curve, I don't want the top one, so I'm going to go to the bottom one, hit enter again, and guess, and I get the same point, x equals 1 something. Right. So I'm looking at the point x equals 1, and I need to find the y values. So if x equals 1, then if I find the y values, y squared equals 1 cubed, so I'm going to get 1. So y equals plus or minus 1. And that will help you find them. Now I could try the other graph. If I put 2 times 1 is 2 plus 3y squared equals 5, 3y squared equals 5 halves, and then, or 5 minus 2, which is 3. Y squared equals 1, and again it's plus or minus 1. So now what I have are the points 1 and plus or minus 1. And so now what I need to do is I need to find out what those derivatives are. So I'm going to take and go 2y dy equals 3x squared dx. Solve for dy over dx, and I get 3x squared over 2y. And if I plug in the points, 3 times 1 squared over 2 times 1, I get 3 halves. And if I plug in 3 over 2, negative 1 squared over negative 1, I get negative 3 halves. This is at the point 1, 1, and this is at the point 1, negative 1, using this curve. Now let's do the same thing with this one. So if I take the derivative, and I go 4x dx plus 6y dy equals 0. 6y dy over dx equals negative 4x. And then dy over dx equals negative 4 over 6y, which is negative 2x over 3y. Now if I plug in 1 and 1, I'm going to get negative 2/3. If I plug in 1 and negative 1, I'm going to get a positive 2/3. So if I look here, is this the opposite reciprocal? Sure it is. And if I look here, is this the opposite reciprocal? Yes.